So good morning and welcome to you all. Thanks for being here for this webinar on talent mobility and development in quantum, which is an initiative by 4 embassies of France from Belgium, Luxembourg, Switzerland, and the Netherlands. And this webinar is part of a series that we regularly organize together. It's a joint effort, and the goal is really to bring together actors of different countries and put them in contact with program coordinators and people that are involved in the educational and scientific and academic domains of a particular subject from France, from the Benelux, from Switzerland. And today we are really focusing on quantum. It's a relatively new subject, really dynamic. So on all kinds of fields, on research, on innovation, also on the economic side, on the political side, but of course also on the educational side. And it's really the goal of France to bring together and to develop this talent development and mobility within Europe, between different countries in Europe. And it's also the strategy of, I know, some other countries that are present today. So it's a perfect time to really dive into the strategies and also the challenges of this development in this particular field, because as we all know, the formation and the development of students, of young engineers, of young research is really necessary in order to have a sufficient amount of people that can bring together this dynamic domain, bring together the challenges that are going to be ahead of us in quantum, in order to be able to get this digitalization, to get this transformation of quantum computers, to integrate it in different aspects of our society. Furthermore, it's also, and that's also why we want to do this with several European countries today, it's to bring together talents all over Europe and to really have an asset also to the development of a European technological sovereignty, and to let young students and young researchers that are at the start of their careers and wanting to go into this domain, to let them have the chance to have experiences abroad, in France, in the Benelux countries, and in Switzerland. So what we are going to do today is look at different national strategies to know what's already ahead, what's already in place, and to see what are the focus points of those different countries. And after that, with the second part, we are going to listen to some pitch sessions of different universities from the 5 countries that are represented today, to get to know already the programs, the developments, and the cooperations that are already there, but also to reach out to new partners, to you as a participant, and to see where there are still cooperations to be organized and to be developed. So we want you to have this as a sort of an introduction of what's already there, and this can be really the first entry point and the first contact point between you as program coordinators. So what we as Embassies of France are trying to do is building bridges, and quantum is really a field that's of importance. So our embassies and my colleagues of the embassies in Belgium, in Luxembourg, in Switzerland, and our embassy in the Netherlands are there for you to develop also these bridges. We have several tools and also cooperational possibilities to help you also to make these trips to other countries, and to go to France and to get financed by the money that the embassies are having in order to get to meet other program coordinators, other researchers, and for students also to go to France and pass time for their studies and for their research. So without further ado, I want to go back to the program and to introduce the first speaker of today, who is Sybille Belot, and she is working at the national program of France for the quantum education, which is called Quantique France, and she will introduce the national strategy of France in terms of education and talent mobility in quantum.
I'm Sybille Belot. I'm project manager for the program Quantique de France, and I'm going to talk about the French national strategy in quantum education and European projects. France's national strategy for quantum technologies focuses on three key areas: research, innovation, and education. France has therefore set up an ambitious training program and asked universities and engineering schools to take part in it. As you can see, our Minister for Higher Education and Research, Sylvie Retailleau, has announced her ambition to train more than 5,000 talents at various levels, from technicians to PhDs. Based on the results of consultations with educational establishments and industry, the quantum strategy is expected to create 16,000 direct and indirect jobs by 2030. This framework is supported by various initiatives at different levels of education, combining initial and continuing training, technical, engineering, management, and entrepreneurial training, as well as training through research. And for us, a national strategy requires a national response. So Quantique de France, led by Grenoble-Alpes University, brings together a consortium of 21 academic French institutions, professional, initial, and continual education, and players in industry and innovation. You can see all the logos on this slide. Quantique de France aims to meet the objectives set out in the national strategy for quantum technologies as part of a drive to accelerate the development of skills and human capital. Quantique de France is implementing concrete actions to meet the growing needs for quantum technology skills among engineers, researchers, researchers, and professors, and also technicians and managers, while consolidating interactions between academics, researchers, and local and national economic players. Indeed, the emergence of new professions encouraged by the national quantum strategy, such as quantum engineers doctors, calls for in-depth reflection on the teaching methods to be adopted. This method preserves the generalist nature of disciplinary and fundamental teaching while promoting interdisciplinarity, a spirit of innovation and integration into the job market. In order to meet the growing needs for skills in quantum technology, it's first necessary to increase the pool of future young talents by making them aware before higher education of the many outlets directly or indirectly linked to quantum technologies. Quantique de France is also developing its bachelor's, master's, and first-year engineering school courses to increase the desire to pursue careers in quantum technologies by developing, for example, cross-disciplinary or specific courses at this level of study. At master's level, while new interdisciplinary courses have been set up from the start of the 2021 academic year to train students in this technological revolution, Quantique de France aims to, as we can see often, train physicists to be more engineers, engineers to know more physicists, computer scientists to awaken to quantum, etc., in line with the objectives in terms of skills to be acquired to meet the needs of industry and research. In this way, new specific courses will continue to open up during the life of the project. And finally, at the same time as these actions, the development of human capital and future talents must necessarily be supported by an ambitious program of continuing and doctoral education. To sum up for this part, Quantique de France develops concrete actions from pre-university training to doctoral training with an ambitious program to found doctoral contracts. Quantique de France is developing initial and continuing training courses in partnerships with professional training and industry players, while participating in the digital transition of training courses as well as raising awareness and popularizing science. And at international level, we need to continue deploying a strategy of targeting talents and raising the profile of national centers of excellence through incentives that offer candidates long-term visibility. And thanks to the acceleration and fundings provided by the French government, our ambition is to train new talents and experts who will participate directly and indirectly, we insist a lot about that, in the growth of quantum technologies. In terms of training, for example, we organize a summer school with the Netherlands and Germany. So this year, 50 students will be coming to Strasbourg for a week in July to listen to various speakers, talk to startups, and work in intercultural teams. Martin from Quantum Delta NL maybe will tell you about it after I've finished. But for France, we're very happy to be working with several voices on this project. And I should point out that we set up this school in only 6 months. So to be continued for this summer school in this first edition. And so with this smooth transition, I'll hand over to Martin from Quantum Delta NL. Thank you.
Thank you, Sibylle. And I think there are really good case studies at the end of what you are doing, not only on the national level, but also internationally. And yeah, it's a good example that you also mentioned the grant, the scholarship, which is also a project that we did with Quantique Edu France and with Quantum Data NL, which offers to Dutch and French students scholarships to go either to the Netherlands or to France, and we had some budget for that this year for the first time, and we set it up also rather quickly. So also with the summer school at Strasbourg, it's also a good example of how we can really develop things very smoothly and stimulate students to go abroad and to develop them further in this field of quantum. Yes, I'm very happy that Martin is already ready, and I will give you the floor, Martin. Thank you.
Thank you, Marnix. Can you confirm you see my slides? Yes? Okay. Well, I will tell you something about the program in the Netherlands, and I will start with a broad overview, if my slide continues. Yes. Well, Quantum Delta Netherlands has a program. It started in 21 with a funding of 650 million euros for 7 years, ending in 28. And we're having this program on all the quantum technologies, on quantum computing, simulation, quantum network, communication, and quantum sensing applications. We do have 4 action lines. The first action line is about research, setting out calls and evaluating proposals, stimulating the more fundamental research and also the more also the applied research. Action line 2 is about creating an ecosystem, helping startups getting started up or getting employees, or helping them with finding a market or extending the market, and that sort of things. Action line 3 is about human capital, and that's where I'm mostly active in. It's I will elaborate on action line 3 shortly. And then action line 4, it's about ethical, legal, or societal aspects of implementing new technologies. It's about research into ethics. It's about outreach to society, and it's about making people aware of quantum technology. One of the milestones we reached with action line 4 is presenting a national course on quantum technology. Very low level, in the sense that everybody can learn something about quantum technology, and we're offering this online for free for everybody to do something with it. Next is like I told you, I would like to tell more about Action Line 3, the human capital. We started the 3 masters. Miriam Blauboer and Jan van de Wetering will tell you more about this further on in this webinar. There's also a professional master in development, which starts in September 25. And it's a master developed by the four universities of applied sciences. Furthermore, we do have quantum talent learning centers, which I will tell you more about in the next slide. We have a sabbatical and visitors program for people to come to the Netherlands or from the Netherlands, do some research or whatever somewhere else. Special about this program is we're also looking for talent from elsewhere and offering them also help with finding schools for children, work for partners, and that sort of things. And what's also makes our Action Line special is we're also offering education for the youngest generation for primary and secondary schools, offering them Q labs where they can come for a day to do all kind of experiments on the quantum level, offering educational material for use at the school itself. We're creating games, and there's also being done some research on the didactics of education of these youngest generation. Quantum talent and learning centers, where there are 4 of them in the quantum hotspots in the Netherlands, Delft, Leiden, Delft with which is quite famous, of course, because of QTech, and where there are also a couple of dozen or so startups located. Eindhoven in the south, in Twente in the east of the Netherlands, and Amsterdam, where QSoft is also located, focusing on quantum software. We are offering a national collaboration, so we're talking a lot with each other and trying to fill in the gaps, having a regional function, looking for companies interested in quantum technology, helping them educate their employees, and helping them with relate to other companies. We're doing this at all levels of education, like I said, primary, secondary, tertiary level. And we're doing with talent learning centers also an outreach towards other organizations like governments, non-profit organizations, and companies, and of course towards other action lines, and other high-tech initiatives like initiatives in semicon or in photonics. We officially opened in November 23. Let's see. So, for example, an example of a talent learning center is Talent Learning Center in Amsterdam, and we're doing internship programs, having a teacher from University of Applied Sciences or a vocational school at a specific company looking for places for students to do internships. We have visits by high school students, offering them in our quantum lab program on quantum technology. We are having developing and starting in September a thematic semester for bachelor students, technical physics on the and then on quantum sensing and enabling technologies. And we are already offered for a couple of years a minor of applied quantum computing, which is now what we call hybridized, which means it's offered offline and online. So it's more easy for students with a longer traveling time to come to visit and attend the minor. Furthermore, we have quantum talks. We do have a workshop introduction quantum computing every Friday afternoon, which is also online, offline, with remote present teachers at universities of applied sciences in the Netherlands. And we, for a couple of years already, offer a workshop, general awareness quantum computing. It's for professionals. It's no previous knowledge necessary. Everybody can join, and it's the first step of awareness for a lot of organizations, companies on quantum computing. In the phase 3, which starts this year, we're going to focus on lifelong development, so courses, seminars, etc. for industry. We will redesign the workshop general awareness to be more specific for economic sectors like telecom or finance. Also offering this awareness not only on quantum computing but also on sensing and security. And we'll start quantum education research labs to do more applied research and offering more courses. And then my last slide, Sabine already mentioned it. We are offering, together with France and Germany, a summer school in Strasbourg, and we're setting up a student exchange between France and the Netherlands. And for the near future, we're probably going to do something with a hackathon, symposium on educating in quantum technology, and also probably making our workshop introduction quantum computing international. So from Netherlands, from France, from Germany, people could join on a Friday afternoon and learn more in a very, very comfortable way about quantum computing. So that's what I would like to tell you. And I think, my email address is on the last slide. Marnix.
Thank you, Martin. Thank you. And please don't hesitate to contact all the speakers. And of course, we will also circulate all your contact details afterwards. Passing on to the next speaker, which is from Belgium. So the representative of the quantum flagship quantum community network, Professor Dr. Milos Nesladek. I can give you the floor.
Thank you. I'm just sharing presentation. Just a second. Okay. All right.
Yeah, perfect. Thanks.
Okay, great, thank you. So thank you for the invitation for this nice occasion. I'm a professor of physics at University of Hasselt in Belgium here, and also at the same time a guest professor at IMEC. And also I represent Belgium quantum community to something which is called a quantum community network, which is kind of the advisory part of the quantum flagship, which gathers all member states. So here I would like to present our activities in Belgium. So let me start with this slide, which actually quantum flagship started with, related to the first revolution, quantum revolution, and also appending to that is Belgian tradition, because we have actually quite a lot of tradition in fundamental quantum science. As you can see, basically 1927 Solvay conference, which was on quantum, was held here in Belgium, and this laid up a basis for many further developments in Belgium, especially in theoretical sciences. So what I'd like to address here is few main bullet points, which is quantum fundamentals, quantum science and technology, education, and quantum industry. So in Belgium, despite we are a small country, so well, there are, as mentioned, according to this tradition, there are many quantum groups at different universities. I listed say the main ones, but there are still some more groups, and all this there are actually different topics covering basically starting from fundamentals to advanced material science for quantum technologies, quantum computing, quantum communication. Especially recently, this has been expanding a lot with development of quantum flagship and quantum science and technologies in general. So we are also having a network of excellence in Belgium, which is called Excellence of Science. And there are several universities partake in this network. And finally, we meet regularly in Brussels at Academy because the ULB, which will be having some presentation later, organizing Belgian Quantum Physics Initiatives, BQPI. And there's roughly bi-monthly, depends on the agenda, but depend bi-monthly organization of the talks of international speakers, of very renowned international speakers, and also following up with discussions of our national activities. So this is more academic network, basically. Everybody can attend, but it's more academic related, like basic science and fundamentals. As concerned industrial applications, we have also a dominant player in Belgium, which is IMEC, Institute for Microelectronics in Leuven. I think most of you know IMEC. And IMEC has a very strong program in quantum technologies related, or appending to their base activities in electronics and microelectronics and nanoelectronics. Especially, there are several domains in IMEC. I just listed a few from the website related to spin qubits, superconducting qubits, cryo integration, cryo structure, and also this is actually my collaboration with IMEC. Because we are both here at the institute. I mean, both affiliation. So we have also working together with IMEC on diamond sensing, where there are quite large activities. And actually, you can see here, well, in this picture here, there was a recent launch on ISSS, which actually, 2023, where one of our devices, which is quantum sensor based on diamond, so this is diamond activity quantum sensor, has been actually in space. This also appends to our engagement and European programs. So there is quite massive engagement in European programs at universities and institutions, including IMEC. And I listed them roughly here, but grouping to different categories. For example, LumiQ is a project which we very partake in purchase of the quantum computer, which will be located in Czech Republic. So there's an international consortium around that. Those projects are related to the quantum communications and also quantum internet. We have quite a lot of activities, as mentioned, in quantum chip development, which is at IMEC, but also part of it at ULB in Brussels. And those projects are related to diamond here. So there are a lot of activities on quantum sensors, but also on, let's say, other topics. So we cover wide domains ranging from fundamentals to say quantum computing, quantum communication, but also quantum hardware and quantum sensors. Just mentioning, for example, in Asterix project, we organized 2 summer schools which were open to international students, which were 2020-2022 in Corsica, and together with Thales in France. And it was quite very successful event. And we have also opened a new project which is called BQCI, which I speak about in a second. And there we also plan to organize a workshop which will be open to different students in quantum. So this is a project. So this is a project which is BQCI. It is one of the quantum communication infrastructure projects of Europe. And there we implement, similar to in other countries, quantum key distribution, which is actually then spread over main stakeholders in Belgium. And also we foresee here cross-border links with Luxembourg. Basically, within this project, all the links to Luxembourg will be built. And also we have quite good relations with Quantum Delta, with our advisory board, but also we have quite a lot of collaboration, for example, with TU Delft. So to education, this is my last slide, 2 slides. So there are several activities at each of the universities. So that we have specific courses on quantum computing, quantum communication. We just mentioned, for example, Ghent University. We have been in Brussels, KU-Leuven, but also in Hasselt we have kind of interdisciplinary course which is called Materiomics. And this Materiomics gathers different domains, including actually chemistry. And quantum pillar is one of the important pillars in this education, because there we educate new generation of scientists for quantum technologies, for material science, quantum material science. As well, we have a collaboration with international universities, for example, University of Ulm in Germany. And this is a final slide. I would like to also show you that we have recently some activities related to the industries, with Belgian industries or industries present in Belgium, better word, have organized something which we call Quantum Circle, which was established last year. And Quantum Circle is should be as a game changer for Belgium for industry applications of quantum. So it's related to international organization like QUIC, Quantum Industry Consortium. And the idea is to make the bridge between all the activities. It means industry, but also research and specifically education, because this is important for a new generation of new developments, which will need a young generation. So this was my last slide. So I would like to thank you for your attention.
Thank you, Milos. It was very interesting to see this overview of Belgium. And I saw also a question in the chat about the workshops, if they are publicly available as well. Can you respond to that?
Pardon me, what was the question?
Yeah, if it's the workshop you were talking about, if these are also, if there is a YouTube link, or are these? Do you have more info about that? It was also quite a question that was asked in the chat.
Yes, definitely I can provide this, because we are actually organizing a new workshop for quantum communication. So we engage in these QCI programs, and there we actually organize this new workshop, quantum communication.
Great.
But also in other European projects, we usually organize such workshops.
Feel free to also share it in the chat if you want, and the others, if you have other questions also for other speakers, feel free to ask them in the chat. So this was to wrap up the strategic part, the overview of a nationwide strategy and activities. And what we are now going to do is to dive into specific programs of specific universities of the countries that are now participating. And I want to start with Luxembourg, Peter Rijen, Professor Dr. Peter Rijen, who's a full professor in computer science and communication and applied security at the Université de Luxembourg. So if you're ready, I can give you the floor. Thanks.
Thanks. Let me try and share from here then.
It's working. Yeah.
Working? Yeah. Okay, and I'll go to full screen. Yes, okay, now I see it. Okay, well, thanks very much for the introduction. So, as said, I'm Professor of Applied Security here at the University of Luxembourg and head of the APSIA Research Lab. And inside that, we have what we call the Quantum Lab, which I'll say a little bit more about in a moment. Just before I launch into that, one comment is, I wasn't entirely clear how best to prepare for this. And on discussion, it was agreed that it was fine if I just presented the work that I in my lab perform. That is actually primarily limited to quantum cryptography and post-quantum cryptography, as I'll describe in a minute. So In terms of a sort of broader strategy at the university or in Luxembourg generally for quantum, as far as I'm aware, we're a bit behind the curve. I mean, listening to the talk so far, it sounds like in Europe there's a lot going on in terms of summer schools and so on and so forth, exchanges. I'm not aware of a real strategy here in Luxembourg, which is something which we should change quickly. But it is, I can say, I know it's a high priority for Luxembourg, quantum technology generally, and indeed we'll be recruiting a new professor in quantum technology soon. Okay, but with that, then let me launch into the talk about what I and my group specifically do. So we're currently, on the last count, 14 members, I think. So apart from myself, we have some research scientists, postdocs, and PhD students. Within that, we have something called the Quantum Lab, which is a virtual lab. It's not a real physical lab, as it were. Currently, it's a little bit small. We lost a few people in the last year or so, but I hope to recruit some more people and build it up again. But just very quickly, so APSIAS, I should perhaps say, stands for Applied Security and Information Assurance. So broadly speaking, we do sort of design and analysis of secure systems, including algorithms and protocols and so on and so forth. We do a lot of work on secure voting systems, for example. More specifically, if we come on to the Quantum Lab, as I mentioned, we're focused primarily on quantum cryptography, quantum key exchange, that's to say, but also some broader, more theoretical notions of quantum crypto. We work a lot on post-quantum cryptography, as I'll say a little bit more in a second. Also hybrid crypto, where you're sort of combining, well, primarily that typically means combining conventional crypto, shall we say, with post-quantum crypto, so you get a sort of belt and braces protection in case one of the, that's the hard problems fails. You still have the other to fall back on. I just included just some publications. I think this needs to be updated. This looks a little bit dated on post-quantum. As you can see, we're working quite a lot on efficient and side channel resistant implementations of post-quantum algorithms. And of course, we're primarily focusing on algorithms which have been emerging from the NIST standardization process. Also, Ehsan Abrahimi in my team in the Quantum Lab works a lot on quantum cryptanalysis and modeling the capabilities of quantum-enabled attackers. So there's quite a lot of work in that area. Let me then quickly mention, so we've been involved in quite a number of projects. Quite a lot of these are sort of QCI type projects, so quantum communication infrastructures. So these are infrastructures, networks which have parts of the network are quantum enabled for quantum key establishment. So there's quite a few. I think one of them was already alluded to, which is, I guess, the Lux QCI, but there's a more specific Luxembourg-based one, Lux 4 QCI, which is kind of similar. There's a larger one called INT, UQKD, which tries to go beyond Europe. So there are partners in Singapore and Canada and so forth. I won't go through all of these. Then we have some more research type projects looking into, for example, future-proofing, making quantum safe electronic systems. We also had a project called Q-Code, which was looking at pushing the boundaries of what you can do in terms of deniability if you have quantum resources available. And the last one here, I'll come back, I've got a full slide on. We actually have a joint project with a company called Lux Trust in Luxembourg. They're basically a sort of identity trust provider for Luxembourg. And they've become concerned about the threat of quantum computing. So we have a joint project with them developing a migration strategy to a post-quantum infrastructure for them. And of course, those kind of techniques can apply to many institutions and companies. Oh, yes, so in fact, this is the slide which says a little bit more about it. So, yes, the goal, as I say, is to develop an effective strategy for migration for Lux Trust to quantum safe. So the first step, obviously, is to draw up an inventory of their sort of current architecture and cryptographic primitives that they use, do a quantum threat analysis and sort of prioritize which are the highest risk components of their infrastructure at the moment, and obviously select, or in some perhaps design or adapt post-quantum primitives, perhaps implement some of them, and broadly speaking, develop a migration plan for them to move forward. Okay, I think that brings me to the end of my slides. Yes, okay, let me come back then. So I hope that was useful and in line with the objectives. As I say, I'm not in a position to say too much about broader strategy in Luxembourg. I think that, as far as I'm aware, still has to be developed, but I think it will be developed. And I'd be certainly very interested in staying in touch with people in this conference to discuss such things. I think I'm on time, I think, yes.
You're perfectly on time.
So,
yeah, thank you, Peter. Yeah, and it's perfectly in line also with the objective of today. Is really to give an insight in what's going on in different countries, and there are different speeds, of course. But it might be the time to really reach out to interesting people and to stay in touch and to develop those links and develop mobility programs and research cooperations, of course. Yeah. So what we are going to do is going to the next speaker, and I see, Peter, that you also received a question, so maybe you can respond in the chat, and we can also later on take the question publicly, so to say. But we are going to move on to the next speaker.
You pronounce my name Peter. I think, is that a Dutch or something way of?
That's sorry. That's the Dutch way of saying it. Yeah.
You don't mind, but just
to say Peter.
Yeah, Peter. Yeah.
Okay. Well, thank you, Peter. And we are going to invite the next speaker, which is Shannon Whitlock from the University of Strasbourg. Please go ahead.
So, good morning, everyone. Thank you for the opportunity to speak here today. Just give me a second to share my screen. Is that okay?
That's perfect. Yeah, thanks.
Okay, so yes, good morning. I'm Shannon Whitlock. I'm a professor and quantum scientist at the University of Strasbourg. You may already know that the University of Strasbourg is one of the biggest universities in France with over 50,000 students. And it also has a very strong emphasis on multidisciplinary research and international cooperation, thanks especially to our geographical location in the border region between France, Germany, and Switzerland, of course. And as you'll see in a moment, both of these aspects have been instrumental in shaping how we build large-scale research and training projects in quantum. So quantum science and quantum technology became a key part of the University of Strasbourg's vision for excellence back in around 2010, 2011. This has now developed into a very fast-growing center for research and education, embodied by the European Center for Quantum Sciences, where I'm located now. Quantum science and technology is inherently interdisciplinary, touching on many different domains of science and engineering. And because of this, we recognize also the need to train a lot more skilled scientists and engineers coming from different backgrounds. And so this has been a driving force behind many of our projects, and a few of which I want to highlight today. So one of the first projects that I was involved in when I arrived in Strasbourg about 6 years ago was QSTEC, Quantum Science and Technology of the European Campus. So this was a trinational doctoral school bringing together the University of Strasbourg in France, the University of Basel in Switzerland, KIT and Uni Freiburg in Germany, and also IBM Research in Zurich as a full partner. This was a European co-fund project, which meant that we needed a strong will to work together, but also very strong institutional support to set up the program. But by working together, we found that we could offer our doctoral researchers a breadth of training and research opportunities, which goes far beyond what any of us could provide in a single institution alone. The first cohort of students of the QSTEC program are now graduating, and QSTEC has become something of a model for European doctoral training in quantum science and technology, which we also plan to continue in the future. For example, just this year, we submitted a follow-up project. It's called GenQ, which builds upon the QSTEC model, but also includes new partners, for example, from the Netherlands and Poland. And we very much hope that this can continue in the future. The second project I wanted to mention is EFFECT, empowering the future experts in quantum science and technology for Europe. This emerged out of a desire to create a joint master degree in quantum technology. But as you probably know, it's very difficult to set up in practice binational master programs, given the local constraints, finding accommodation, different academic calendars, and so forth. So EFFECT solves this in a way by offering students a complementary certificate on top of their master degree, which they perform at home, but with a very strong international emphasis, encouraging, for example, mobility, providing extra training, networking opportunities, for example, through mentoring, meetups, hackathons, schools, and also interaction with experts from academia and industry. And so now we're eager to bring our experiences with QSTEC and EFFECT and other similar projects to the wider communities. And we're doing this through projects like Quantedu France, you heard of already this morning, and also DigiQ, which is a little bit the counterpart at the European level. It's a primary workforce development project of the European quantum flagship, which we participate to as a level A partner. In turn, these projects have also provided the extra necessary push needed for us to restructure our training at home. For example, as a direct consequence of these projects, we're in the process of creating a new engineering track and master program in quantum technologies at the University of Strasbourg. The first cohort will start in September this year. And the program is a bit special because we're building it really from scratch. It contains more than 30 ECTS of new courses, advanced practicals, things like this. But also we include explicitly into the curriculum the possibility to participate to courses abroad through these larger networks. Maybe to conclude, let me just emphasize that education is a very important driver for building a sustainable quantum ecosystem. And our experiences with this actually can also serve as a model for other frontier fields. Cross-border cooperation and access to talent is a unique advantage for Europe. And I can say our students benefit enormously from the extra intercultural experience, networking, greater access to research infrastructure, and much more. Many of our projects were bottom-up initiatives, but it's clear that we need reliable funding and also institutional and political support to overcome many of the challenges there are in establishing and sustaining ambitious educational projects. And finally, on mobility, my impression is that actually we have a lot of instruments for supporting mobility, such as Erasmus+, which is a great program. But students also naturally have some inertia. And a great way to overcome this, in my experience, is to involve students as early as possible as part of the international community, create professional networks, and give them, let's say, the means to be aware of the very special opportunities that they have here in Europe. That's all. Thank you.
Thank you, Shannon. Very interesting and good that you say, and I totally agree. And I think everyone that quantum is really going beyond national borders. So it's really interesting to, especially in Europe, to think cross-border and to think internationally. So I hope that you inspired other colleagues and that there are some colleagues interested in reaching out to you. Going back to the Netherlands with Dr. Mirjam Blauboer, and thanks for being here. which is an associate professor at TU Delft, and also active in Quantum Data NL as lead of the Human Capital Action Line. So please take the floor and let's see if everything's working.
Yeah, thank you very much, Marnix. Just trying to share my my slides. Hang on a second. All right. Can you see the slides?
I think it's coming. It's loading now. Yeah.
Oh,
that's
okay.
perfect.
Okay. Okay.
Thank you, Miriam.
Yeah, thank you very much, Marnix. So, hello everyone. My name is Mirjam Blauboer. I am working at Delft University of Technology in the Netherlands. I am a physicist by training and here an associate professor. I have a research group in theoretical quantum nanoscience, and I'm also very active in quantum education, which is what I hope to talk about here. And specifically on two topics, but the first one only very briefly, because Martin has already been telling you about this. So a few words, one slide on Quantum Delta NL that both Martin and I are very active in, and specifically on the education and training efforts that we are doing in this network. And then I will talk a little bit more about the master program on quantum science and technology that we have developed here, co-developed with Leiden University, which is a multidisciplinary master program that started in the past September, and is specifically focusing on quantum technology. I see that my numbering has 2 1s, but it should be a 1 and a 2. So sorry for that. So first about Quantum Delta. Here you see the same picture that Martin had in his presentation, but with a different color coding. So in my case, it is blue. Never mind, it's exactly the same content. So I won't explain it because it has already been done. But it is the our national Dutch ecosystem for developing a quantum ecosystem at all levels. So both for companies, but also in terms of developing training and education. And on this last part, there is the Action Line 3 that was mentioned. And within Action Line 3, Martin also already mentioned, we have a couple of initiatives. In my case, I have listed them as 4. So we have developed a national menu, if you like, of multidisciplinary master programs or tracks. There are 2 full new master programs, one in Delft and Leiden and one in Amsterdam. And John van der Wetering, who's also here, will tell you a little bit later about the Amsterdam one. I will be telling you about the Delft-Leiden one. And then there are also new tracks in different parts of the countries at the University of Twente, which is in the east of the Netherlands, Eindhoven, pretty much in the south, and Maastricht, very much in the south, close to Belgium. So there they have, so together these programs or tracks form a kind of a national menu that students can choose from if they're interested in studying quantum technology. There's also a professional master under construction, already very advanced, that is developed by 4 universities of applied sciences together. So they will offer this master, hopefully starting in 2025. And there is a specialization for vocational college students on instrument making for quantum technology applications that is also developed in Leiden, but will be made available on a national level. Then there are the Quantum Talent and Learning Centers that Martin has talked about quite extensively. And 2 other initiatives within the Action Line 3 are, there is a fund for sabbaticals and exchange of talent, both inbound and outbound. So if you would like to come to the Netherlands for a while and work on something related to quantum education here, or you would like to invite someone from the Netherlands, there is a fund for that within Quantum Delta. And we also have activities and initiatives for the youngest generation, everyone who's under 18 and still in school, in terms of Q labs, 4 Q labs throughout the country, games, research on didactics, and so on. So now this is the general ecosystem. Now let's focus on the master program we have locally developed here. So it's called Quantum Information Science and Technology. I was the lead of the development team, and I am now the director of studies of this program. The acronym is QUIST. So it's a joint degree between Delft University of Technology and Leiden University and QTech, which is not a university, but a research institute, but they're also heavily involved in this. So we have lecturers from all these three institutes, and the students, they travel between Delft and Leiden. They spend 3 days in Delft per week and 2 days in Leiden. And the idea was that in this way, they could really make use of all the expertise that the two universities together can offer. So it's a multidisciplinary master program. It admits students with a bachelor in either physics, mathematics, computer science, electrical engineering, and astronomy. And we started, we're now in our first year. We started with our first 20 students. You see them on the picture here in September 2023. So in terms of context and curriculum, and I think Shannon and Peter also before mentioned elements of this. So our guiding principles in developing this program were, we wanted to train what is called deep generalists, because if you develop a multidisciplinary program, there's always the risk that you teach everything, but on a too shallow level, right? Or you focus too much on one thing and lose the multidisciplinarity. So to combine this, we coined this term deep generalists, meaning that every student throughout the 2 years will be trained in depth in quantum hardware aspects, quantum software aspects, programming, but also in electronics for quantum technologies, because it's an engineering degree. And at the same time, in their second year, they specialize in one of the application areas of quantum technology. They can opt for specializing in quantum computing, so more the physics hardware side. They can opt for quantum communication, which is related to what Peter's research in Luxembourg is about, so more on the quantum crypto side, or they can specialize in quantum sensing. So they develop in this way in-depth knowledge of all the elements that are necessary to build quantum information processing devices or networks, and they specialize in one of the application areas. And the focus of the program is really on multidisciplinary teamwork. There are 2 large team projects, one in the first year and one in the second year. Both involve companies. So around Delft and Leiden, we have a smallish but non-negligible ecosystem of startup companies, Q-Blocks, Orange Quantum Systems, and some of them are actually also growing at a very fast rate now. So these companies provide challenging problems that students in multidisciplinary teams, we team up students that come from different bachelor programs, work on during a quarter of a year. And also we focus on challenge-based learning with a view towards the future of these graduates who will be in a world where lifelong learning becomes increasingly important. So to prepare them for this, many of the aspects in our curriculum are challenge-based. And here you see a picture of the curriculum, very small. I will not discuss it. I hope you can even read it. But if you're interested, contact me and I can provide more information. So with a view towards the future and also towards cross-border collaboration, we started with 20 students. Right now, we're doing admissions for the next year, and the interest in the program is quite large. We have a cap of 100 students, and we may already reach that number in the coming year. The next cohort starting this September may already be of that size. We don't know because we don't know if everyone that we admit will actually come to Delft, but the interest is very large. My personal aim is also to forge more connections to sister programs in the EU. So multidisciplinary master programs on quantum science and technology. So far we have been very busy locally and on a national level. And on my to-do list now is I would very much like to connect more across the border to European programs. And some of you have mentioned some ones. So I hope there is some collaboration possible there. We're also looking to develop exchange opportunities, especially at the master thesis stage. So exchanging master theses who are doing their research programs with other universities in Europe. That's something that we're working on now. And we're very interested to get in touch with companies, because company cases for our teamwork is really the heart of this program. So if you know of a nice company in France that would like to welcome a team of 5 intelligent students for a while and work with them on a nice assignment, then we're very much interested to hear about this. In reverse, we have companies here that are also interested to have smart students around. So the exchange, I think that many of you mentioned, is also I would be very interested to join there. So that was all I had, Marnix. I will maybe check the chat and hand back to you.
Thank you, Miriam, and very, very interesting. And congratulations for the success already of the program. And what's also interesting is that and Martin mentioned that as well, to have this integral education, so on all levels, also vocational, also middle school, from a very young age, but also the applied universities. And I think that's really the way to go. So thank you for that, and duly noted for the wish to cooperate internationally. So what we're going to do now is to invite Dr. Mathieu Salah, who works at the Université Bourgogne-Franche-Comté in the east of France, and he is the project manager of Quantique, which is a Erasmus Mundus joint program. So please take the floor, and I see that Miriam still has her presentation, so if you could close that one, and then Mathieu can present his. Normally there's a little cross somewhere at your screen.
Looking for the cross, Marnix?
So somewhere above. Do you see it?
I don't see it.
I can also take the control. So I will
take the control. Yeah, thank you.
Thanks.
Thank you very much.
Thank you.
No problem. So Mathieu, go ahead.
Yes,
Yeah.
I'm trying to share my screen now.
Great.
Okay, I will put in full screen mode. All right, can you see my screen now?
That's perfect, Mathieu. Yeah.
Yes, thank you. Hello, everyone. So I am Mathieu Salah. I'm the manager of the Erasmus Mundus Master in Quantum Technologies and Engineering. So Quantique. So I am located in Dijon at Université de Bourgogne. So it's in the east of France. As you can see here, we have a nice picture of our university campus here. And I am working in in a big lab called ICB, so Laboratoire Interdisciplinaire Carnot de Bourgogne. So it's a big lab, over 300 people working in multidisciplinary aspects of physics, chemistry, and engineering sciences. And I will first say a few words about the activities in quantum technologies at ICB. So we are a team of physicists mainly, and also mathematicians. So we have 2 mathematicians also in the team. So this team has been already involved in a few large-scale European networks. So you can see the LIMQuET and Cusco projects, which were both active until 2021. I think I remember. So we were coordinating the LIMQuET project, and Cusco. So we were a partner of the Cusco network, and the goal was to train a generation of PhD students through a large-scale research project in quantum technologies. With a number of partners in Europe. You can see some of them listed here. So already these were already actions in training talents in quantum technologies. In terms of research, very quickly, the team has been developing the theory of the control of quantum systems for more than 20 years now. And we apply these theories to various aspects in quantum technologies and beyond. You have a few examples here of applications in quantum computation on the IBM quantum computer, an illustration of collaboration with experimental colleagues in Oxford on quantum communication, where researchers are able to shape single photons to have the shape and size of the Tower Bridge in London. On the left, you can see this nice picture where experimentalist colleagues in Toulouse are able to write quantum with both Einstein condensates, and you actually need to do optimal control to be able to control those Bose-Einstein condensates to write everything you want like this. And so we have a number of other lines of applications of the tools that are developed in the team. You can see some examples here to the rotation of classical and quantum systems, chemical reactions, so the quantum control of chemical reaction, quantum sensing, imaging through magnetic resonance, or the control of nonlinear systems. And we have been also involved. So in this team, I've been myself involved in research for quite some years, and I've been moving to managing projects now a few years ago now. So we are involved also in training actions. We have co-founded the AFI Graduate School, which supports international master programs, PhD programs, and research programs at the scale of the region, here around Dijon and Besançon. We are part of the Comté du France initiative that you heard about at the beginning of this webinar, and we are now developing the Quantum Master Program since 2022. So Quantum is an Erasmus Mundus Master Program, so we are funded by the Erasmus Plus program of the EU to develop a joint master program in quantum technologies with our partners. So here we are Université de Bourgogne is coordinating this program, and we have the Technical University in Kaiserslautern, Landau in Germany, and Aarhus University in Denmark as our partners. And the EU is offering generous funding for these institutions to develop this program and to propose very attractive scholarships for students from all over the world to come to our universities to study. Here are the people involved: Stéphane Guérin here in Dijon, Arthur Videra in Kaiserslautern, and Jan Alt in Aarhus, and our colleagues from international relations who help us a lot to managing these programs. And we build on a long experience in managing international physics master programs to build this quantum program. So we are very fortunate to have a number of associated partners, and most of them from industry. Ranging from startups to multinational companies, and we are very happy to see that companies are really happy to collaborate with us and to come and participate in training our students in quantum technologies. Just a peek at our program. I will just describe the structure briefly. So the students start in Dijon with a core courses program to make sure that everybody is on the right level in the fundamentals. And then for the second and third semester, students can specialize in various specializations, which are, of course, reflect the research expertise in our universities. So photonics in Dijon for the second semester, photonics and nanophotonics, or quantum optics in Kaiserslautern, so more theoretical. And for the third semester, either many body quantum physics in Kaiserslautern or platform for quantum technology in AU. Although the third semester is extremely flexible with a lot of elective courses, so that students can really tailor their program according to what they have done before and what they want to do after. So basically, what our approach is that we want to train students to have a strong background in the fundamentals of quantum physics, both theoretically and experimentally. And we have also, of course, dedicated courses on quantum technologies, on all aspects of quantum technologies. And students require also a strong lab experience so that they are really equipped to go to work in the industry afterwards or in a research lab. We have organized quite a few seasonal schools. So there are 2 schools in the program. Students attend a winter school after their first semester in the first year, and a summer school at the end of the program. So we have organized already 2 winter schools and 1 summer school. And these were very successful events, to our opinion, with many industrial partners coming to present their activities to the students, also academic professors in quantum technologies, but also beyond. We had a researcher from CERN showing his activity on the production of anti-hydrogen, or talks in quantum effect in chemistry or in photonics for health industry, and so on and so forth, so that students have a broad overview of what they can do with the training they receive in quantum, and also, of course, increase their network. Just to finish, I show you our first 2 cohorts of students. The first one started in 2022, and they are now about to finish and graduate. And we will welcome a new cohort of students in September now. We will welcome 24 students from all over the world, with slightly more students, even significantly more students from EU, which is also a nice thing. And yeah, and with this, I thank you for your attention, and I'm happy to work to answer questions if there are some.
Thank you, Mathieu. And yes, feel free to ask some questions in the chat. And we also, after all the presentations, we have some time left for questions. Good to see that also this is a recent initiative, and that it also gives already some fruits already, that your efforts also pay out. So that's really nice. We're going back to the Netherlands again with John de Wetering van de Wetering, Assistant Professor at the Informatics Institute of the University of Amsterdam. I see already you put your slide, so it's working. And please take the floor.
All right, thank you. Can everyone hear me clearly and see my screen?
Yeah, it's perfect, John. Yeah.
Great. Okay. Yeah, so I will be telling you a little bit about our new master program at the University of Amsterdam called Quantum Computer Science. Yeah, and I'm going to keep this brief. So first of all, I think the way we distinguish ourselves with the master that Miriam described in Delft, also what Mathieu was talking about, is that our focus is really on theoretical research. So we are explicitly not an engineering program. We are a computer science program. So we are focusing on quantum algorithms and quantum information theory. This is made possible by our lecturers, which are all very internationally acclaimed researchers from QSoft. We have a large group of senior researchers there who are all very excited to start working in this program. And yeah, and as Miriam also explained and Martin explained, we have this big program in the Netherlands called Quantum Delta, which gives us a lot of funding, a lot of opportunities to work together with other places in the Netherlands. And yeah, there's a lot of interest of many companies and startups to work with our prospective students or new students that we will have in the future. So very briefly, this is Amsterdam Science Park. This is where the new master will take place. This is a bit of an older picture. So here in the middle where it says Lab 42, there's like a blank spot, but there's a building right now. But then in the spot next to here, there's going to be a new building built, which is Lab Q. And this is supposed to be done at the end of 2026, so we can start using it in the academic year 2027. And this is a center where we're going to combine research, education, and industry all on the quantum side in one building. So there's going to be like different floors for students and for researchers and for companies to have some space there. Yeah, and all the quantum activities at the University of Amsterdam are going to be focused in this one building. Yeah, so briefly about the program. So yeah, this is a very research-based program. So there is a small selection of core courses that every student has to follow, but then there is a large selection of specialized courses that the students can choose from, which prepare them for their master thesis research. And these are all taught by experts in their field, and the courses are based on the expertise we have available at the University of Amsterdam. And yeah, and to repeat again, like we have a focus on the theoretical aspects. So we are not an engineering program. We have a strong mathematical focus. So one of our entry requirements is that the students have the equivalent of a minor in mathematics. So we don't accept, in principle, just any physics or say computer science students. They have to have shown an affinity with mathematics. And this is necessary because some of our core courses are actually part of the Dutch Master Math program. So they're actually they're actually courses that also exist in the Master Mathematics. Yeah, so then since this meeting is all about collaborations, outside collaborations, I can be quite brief about this. So we are starting this program this September. So we've been hard at work trying to get everything ready to go. So our focus has been on making this program work at university. So currently we don't have any collaborations set up with other universities or sort of ways to exchange. There are a couple of potential things happening. So with Miriam, we talked briefly about like in the future having a potential kind of a way to collaborate with the Quizmaster in Delft-Leiden. We also have a current proposal going on for to get some funding for exchanges with the new UK doctoral training centers for quantum technologies. So these are centers in Edinburgh and London and Oxford and one more place, I think. And so we're hopefully going to get some money to exchange students between them and here. But yeah, we are very excited to give our students more opportunities to do exchanges with companies or other universities, and also to bring other students to our place. So yeah, definitely feel free to reach out and let us know if you're interested in doing anything like that. And yeah, and that's it. That's what I wanted to say for now.
Thank you very much, John, for your time and the clear presentation, and also best of luck with setting up that program. Yeah, we're going on with a new speaker, Professor David Ferrand. You already heard him a minute ago, from the University of Grenoble-Alpes.
Yes, do you hear me?
Yes. Yeah.
Okay, I will try to share my screen. Should I choose fenêtre or écran? Okay. I don't know.
Both of them are fine, but fenêtre, then you can really choose a specific.
But when I click, it's not ready. If I make this, no. Just a second, because écran complet. Okay. Do you see my screen? I think.
Yeah.
Okay,
and then
you go to the first. Could you see my first slide?
Yeah, you can make it bigger as well if you click on
now it should be full screen, is it?
No.
Because
not yet. Yes, now it's full screen.
Okay. So there is a delay.
It's a delay. Yeah. Okay.
So okay. Hello everybody. I'm David Ferrand. I'm professor at the Department of Physics at University Grenoble-Alpes. And in fact, I'm here because I'm coordinating new training programs for UGA. This training program are regrouping master students for the physics department, but also engineer students. So, and I will try to highlight the mobility opportunities, and I will try to also to say a few words about our European master program, which is called EMM Nano. It's a well-established European Erasmus Mundus program. And in 2021, we include new tracks, 2 new tracks in quantum, and one of them is carry on for the second year in Grenoble. So it was my outline. So I will go very briefly, just you will have all the materials in my slide later on. So one word about the strengths of Grenoble in quantum, then the present international master offer, the mobilities, and then the Erasmus Mundus master program EMM Nano. So why we developed or we enlarged training offer in quantum in Grenoble, it's because due to the history, Grenoble is particularly strong in this field due to a lot of research in condensed matter physics and also in microelectronics. So now we have a research federation. You can go on this website, it's called Quantalps. It regroups more than 200 researchers in 18 different labs. You will see the different labs. It goes to physics, engineering, mathematics, and a lot of area, including laboratories from CEA centers, from CNRS, and from associated labs with university. And it covers with the topics, almost the different hot topics in quantum. The most of them is quantum engineering and hardware with a lot of involvement in solid state cubics, for instance, but also photons, the quantum informations, quantum matter, but also key enabling technology with low temperatures and high frequency instrumentations. So we have also a partnership with industry. We have the big company, the biggest company in the department is ST Microelectronics, as you know. There is also R&D labs like Leti or companies like Soitec, but also emerging startups that emerged during the last years. This is Kobli. This is one of the national startups on silicon qubits, which is in Grenoble. And also we have something like Silent Waves that works on superconducting qubits. And this company, this startup company, is developing some amplifiers based on Joseph junctions. So what about the master programs? We have also, like other universities, international master programs. What is quite more specific in why you will see we try to regroup engineers and master students. And these tracks are fully in English. They're open to international students. As I said, we regroup master and engineers. We have entrance possibilities in first year and in second years. And I think maybe what I would like to insist that we have possibilities to exchange flexible exchange during master and engineer internships. Maybe this is one point that we have to highlight in this presentation, I think. So one word about UGA, okay, it's like Strasbourg and others. It's one of the big university outside Paris with almost 60,000 students. And what about quantum? We started a program which is called the Quantum Thematic Program, and within a structure, this is called UGA graduate schools. And it regroups in this program all the masters and engineer tracks in physics related to the quantum technologies. It's a 2-year program. The goal is to propose a fundamental training in physics, but also covering applications. And you see that in year 1, we have 2 entrants, a master 1 from the physics department, nanophysics, quantum physics, and also another entrance for engineers coming from the engineer school FELMA, photonics, electronics, and materials from the Grenoble INP Institute of Engineering. For year 2, we have 3 specialties. The middle one is a new one that has been created 2 years ago. It's fully dedicated to quantum. It's a quantum information and quantum engineering master track. But also we try to cover a larger audience. We include master 2, which is on nanophysics, and a master 2 on photonics and semiconductors. And okay, you will see on this slide, you will click on the different links. You will have the different details about the different master tracks here. But what I would like to insist is what we do within these 3 tracks. It's a common training. We succeed to put together. It's all these students. It's mixed. It's from 30 to 35 students each year. We propose some fundamental courses to put all the students at a good level in quantum physics. We have a lot of efforts on quantum lab works in dedicated platforms and research laboratories. And it's going up because we have a new lab works which are in preparation, for instance, working at low temperatures and even in millikelvin for solid state qubits. We are trying to develop links with industry, with opening seminars and with scientists or people from industry covering startups or big companies. For the moment, it's mostly French companies, but we are really open to cover also companies from Europe also. And we have also some integration events and the developments of interaction from master and engineer with students that are already doing their PhD in quantum. So what about mobilities? Here I regroup the different options. On the left-hand side, you have the master and mobility for at level of master and engineer. We have many scholarship opportunities to welcome students to do their master in Grenoble. And but we have also maybe, which is more appropriate to this presentation, as I saw that there are quantum master track almost everywhere in France and in Europe. Maybe we have also possibilities to have outgoing master scholarship to support master engineer internship abroad, from 2 to 6 months. And I would like to highlight that for engineer school in France, there is mandatory mobility of 17 weeks. So for a young student who would like to do a mobility, would be happy to promote links towards good universities in Europe. We have also financial support to welcome students for master internship coming from Belgium, Netherlands, Switzerland, or any other places. For PhD, we have also several PhD fundings from the UGA itself, but from ANR and also for a Marie Curie co-funded PhD program. There are 2 specific calls per year, one in spring, one in fall. So, okay, you can look at this link, you will have the different calls. And for the Quang Marie Curie, it's restricted to Marie Curie students. It means it is open to students that have spent less than 12 months in France. So it's well designed for European students. And for the collaborations, maybe it's also possible via these programs to support the building and to co-finance co-tutel PhD thesis between European partners. So it would be an option. We have money there to participate to the building of a co-tutel thesis in the field. The last point is our Erasmus Mundus European Master Program called EMM Nano Plus. You can see on this view graph that it's a 2-year program. It regroups 5 European universities. The coordination is done in Belgium by KU Leuven University, and it has been built as a program on covering nanoscience and nanotechnologies. But in 2021, we enlarged the topics towards quantum technology with 2 new tracks, one in Grenoble and the second one on the top here in Chalmers, Göteborg. So the mobility, okay, you can see this is a quite broad program with 9 options, but 2 of them are covering quantum. And moreover, the mobility scheme, all the students, they are doing their first year in Leuven, and thereafter they are spread for the second year for the specialties in the different places. So what about the quantum engineering track? As I said, the year 1, it is done at KU Leuven in Belgium. So you have a selected syllabus. The syllabus of year 1 is quite broad because it covers 9 options, but I regroup here the topics covering for students going both in Chalmers or in Grenoble for quantum. You can see, okay, you can see later on you have a lot of courses in quantum that prepare the student to do the year 2 options at the UGA. So it's like the local master program. It's a track where students can select a full curriculum of courses fully dedicated on quantum, with covering solid-state qubits, quantum condensed matter, enabling technology, micro nanofabrication, quantum optics, and so on. And I think that's it for my presentation.
Thank you, David, and really insightful. So with the aspects on internships and the cooperation also with enterprises and startups. Thank you so much. And now we are going to the last speaker, last but not least, I would like to say, which is Professor Serge Masser from the Université Libre de Bruxelles in Brussels. So if you're ready, please go ahead. And thanks for your time.
Hello, can you hear
me? Yeah, we can hear you, we can see it. You can just make the screen bigger, and then you're good to go.
This is okay?
You can make it bigger still. Maybe that's the same delay as we just had. If below you have the you see the icon below. Yeah, still going on.
I can't.
Okay.
I don't know what I have to do.
You see this?
You can see right the slide where you can zoom as well, all the way below. And you have
you can put it full screen normally, because now we can see the slides also on the side.
You can see the slides, but I can't see them, so I don't know why.
Yes,
I hear you're on the bottom.
There you have to go. Yeah.
Click.
This is good for you.
Click. Yeah, you can click there.
Okay. Well, anyway, I'll be very quick. I'm just going to present very quickly our activities in quantum sciences in Brussels at the Université Libre de Bruxelles. So very quickly, we've been active in this area for quite a long time, I think basically since 1998. And nowadays, the university counts, I think, 7 faculty in this area. And our main focus is on theory. Well, most of these, we're in physics, in science and physics, or in engineering faculty, but most of us are theorists, and there's one experimentalist in quantum optics. We have a long history of collaborations with France, the Netherlands, Switzerland, both through informal collaborations and through European projects. And one point I wanted to mention is that we are starting, not this year, but in autumn 2025, in our physics curriculum, a new orientation devoted to quantum sciences. So this, I think, will be the first real quantum science-oriented training, or one of the first in Belgium. It'll be more like theory-focused, physics theory-focused, because this is our strength. And yeah, it's probably possible, as this builds up, to build connections with other similar programs elsewhere, as we've been hearing today. So the other thing I wanted to do is just to go very quickly over the different people here and their expertise. So I'm doing this very quickly. I put in bold some keywords. So, well, Nicolas Serre has been mainly working on continuous variable quantum information and quantum cryptography. Ognian Oreshkov on causal models. I mean, everybody has been doing many other things, but this is just some overview. Jérémy Roland has mainly been working on quantum algorithms. For instance, random walks, quantum walks. Myself, I've been working a lot on quantum non-locality and quantum optics. Stefano Pironio, a lot on different aspects of quantum cryptography, device-independent quantum cryptography. Stéphane Clément, he's our experimentalist on quantum optics, and also a lot on integrated optics. and Nathan Goldman on different aspects of topological quantum states, cold gases, quantum simulations from the theory point of view. And as Milos mentioned earlier today, he's the organizer of our Belgium Quantum Physics Initiative, which sort of informally brings together once every 2 months all the researchers in quantum sciences in Belgium for an afternoon of networking and listening to talks. And yeah, that's all I had to say in this very quick overview. So thank you for your attention.
Thank you, Professor Serge, for this good presentation, good insight of what the Université Libre de Bruxelles is doing. I think you can just, I can also...
I should stop. There
yeah,
I am.
Yeah, perfect, thanks. Before wrapping up, because we also have like 15 minutes for questions, but I want to do a wrap up also to end it very well, and then you can stay, of course, to ask you some questions and also to reach out, do the reach out. What I want to say something about a specific program that our Embassy of France in the Netherlands, together with Quantique de France and Quantum Data NL, developed. And we already mentioned it, but I want to paste also the link in the chat, and I will share my screen so you can also see it. That's a scholarship program that we developed, Excellence Quantum scholarships for students from the Netherlands or from France to go to either the Netherlands or France for a certain amount of time for the master's program. It can also be meant for young research, for PhDers to do sort of an internship or a research mobility program. It can be very flexible, so it can be up to 1 year of finance, can also be very flexible for from 1 month to 2 months to 6 months. So if you have candidates coming from the Netherlands in France and you want also to finance them, please contact us as well and let them know that there is some financing available, because that can also be another stimulus for the students and young researchers to go abroad. And the same goes also for the Dutch coordinators who receive French students. So if you want to know more about it, please go to the website or contact us. And I will be more than happy to answer your questions. And the end is here indicated on April the 30th, but that's not the case. We are going to continue it, so it's still on this date. But we just decided also to continue this call and to have just regular evaluations, especially for young researchers. There's not a certain deadline that we want to respect. We want to give them also the chance to really give in those candidatures very flexibly. So that's one point I want to address, and also in general for all the embassies of the 4 countries, we have financing also available to receive researchers, can be senior researchers, but also junior ones, to go to France or to host them, researchers from France. To go to the countries that we are working in. So please don't hesitate to contact us if you want to reach out, to do a mission, to visit your colleagues. Please also keep us in the loop and we can see what's possible for you. And we're more than happy also to get in touch with you and to develop with you these links and to build bridges together. So once again, here are the names that are responsible in the several countries from the 4 embassies. And I also want to grasp the opportunity to thank my colleagues, especially Charlotte Venema from the French Embassy in Belgium, Marina Daniel from the French Embassy in Luxembourg and the Institut Français in Luxembourg, and also Olivier Blanchet from the French Embassy in Switzerland. So please feel free to reach us and contact us. So I want to thank you for your attention, for your time as well, for the speakers, and the coordinators that also contacted the several speakers. Thank you very much. I found it very interesting to see at what point already things are developing, and to see that recent initiative already gets some success. So congratulations with that, and keep up the good spirit. And now I want to give the floor to all the participants and to see if there are any questions. Please go ahead.
There's one question in the chat. Can you later share the slides with contact address